Welcome, ladies and gentlemen, to part 2 of our video on section 3.1, the derivative at a point. The first video was trying, hopefully pretty successfully, to explain the concept of the derivative. Uh, the concept, the short version is, the derivative is what you get when you take a slope, and instead of looking at what happens between 2 points and getting a secant line that stretches between those points, you shrink the distance between them down to nothing using the idea of limits. That distance, you take the limit as the distance between your 2 points goes to 0. And now instead of a secant, you have a tangent line that just touches at 1 point instead of crosses at 2. And you take the slope of that tangent line, and then you can talk about the slope of a curve at 1 point. And that's the crucial idea for like 90% of Calc 1. So let's practice doing that a couple more times. I have here a function f of x equals x squared minus 2x plus 13. Pretty standard issue quadratic. And we're going to find the slope of the tangent line when a is 2. This m tan is, for now, this is how we're going to write this idea of a derivative. M tan is just the slope of the tangent line. So you'll see this a lot. We'll get better notation for this pretty soon, so don't fall in love with m tan. It's going to change. But for now, m tan will do the job. And m tan is the limit as h approaches 0 of f of a plus h minus f of a all over h. This is the limit of a difference quotient. That will always get you the slope of the tangent, which is, moving forward, we're going to call it a derivative. And to do these problems, you're just going to take the difference quotient, just like we have done in section 1. And then after you get your difference quotient, you plug in h equals 0. These are all going to be, these are all limit problems, but they're all always going to be plan B limit problems, because plugging in h equals 0 without simplifying is always going to fail. So that's why we do the difference quotient and we simplify, and then we plug in h equals 0 at the end, and we get ourselves a slope. So let's see what that looks like. Oh, actually, before we start, let me give a word of advice. When you do these problems, write this out every single time. This should always be the first thing that you write. This is step 0. Before you even do step 1, write down this thing. You're going to be using this thing. This is like the formula. This is the magic equation. You're going to be using this over and over and over again for a while. It's going to help you a lot if you get really practiced writing it down. So write it down every time. Step 1, after you have finished step 0 by writing this down, step 1 is we're going to take the limit as h goes to 0. This piece we're just going to carry down for a while. Resolving this limit as h goes to 0 is going to be like the last thing we do. So just keep writing it over and over again until you get to the end. We're going to plug our function into this difference quotient, and we're going to plug in a at the same time. So this is going to be f of 2 plus h should be 2 plus h squared minus 2 times 2 plus h plus 13. This is f of a plus h. F of 2 should be 2 squared minus 2 times 2 plus 13. And then we can divide all of this by h. Now we have to do a lot of distribution and simplifying, just like we did when we did difference quotients the first time. The only difference is we're going to write limit as h goes to 0 just to the left of it for each step. This should be 4 plus 4h plus h squared minus 4 minus 2h plus 13 minus 4 plus 4 minus 13. We still have to distribute this negative sign in there. And just like we did when we were doing difference quotients the first time, almost all of this stuff will cancel. And sort of the same rules apply. When we first did these, the rule was everything that doesn't have an h in it should cancel, which includes all of this on the back end. This has no h's, it should all cancel. And it does. My 2 squared cancels with my 2 squared. Use triangles for that one. My positive 4 cancels with my negative 4. And my 13 cancels with my negative 13. I'll put squares on that one. All of this stuff cancels, which leaves me with the limit as h goes to 0 of 4h plus h squared minus 2h all over h. And we can clean that up a little bit as well. I'm just going to take the h out of the bottom at the same time that I combine like terms here. So the 4h minus 2h leaves you with 2h left on top, and then you take an h out of everything. The 2h on top is just going to turn into a 2. H squared will turn into an h. So the limit, I forgot the limit. Stand by. Still taking the limit as h goes to 0 of all this. Again, 4h minus 2h is 2 over h is 2. H squared over h is h. This is the step. This step where you cancel the h from the bottom. This is the step where you can now hit this with plan B to actually evaluate this limit, and when you plug in h equals 0 to this, you should get 2. So, I don't know what x squared minus 2x plus 13 looks like. It's probably some parabola that does something like this, I guess. But I do know that at x equals 2, the slope of the tangent line is 2. So that's what these problems look like start to finish. Let's do another one. What am I at? 7 minutes? Yeah, we can fit another one in this video. I found a marker that doesn't erase well. Good thing I have one of these. Okay. So we've done this with a couple polynomials. I think it's time we did something more interesting than polynomial. I want to see what happens if we do this to a pretty simple looking rational function. So let's say f of x equals, we'll go with 7 over x plus 3. And I want the slope of the tangent line when a is, let's say, negative 1. So this is probably going to be some kind of rational function with a vertical asymptote at negative 3. So it's probably doing this and this. I want the slope here. I'm expecting a gentle negative. Let's see. To get the m10, I need to do the limit as h goes to 0 of f of a plus h minus f of a over h, and I'm going to write down this step 0 every single time. And then I'm going to plug the function into this and see what happens. I should get the limit as h goes to 0 of f of a plus h when a is negative 1 should be 7 over a, let's do negative 1 plus plus h plus 3. This is the denominator. Minus 7 over negative 1 plus 3. All divided by h. I have created a horrifying mess. I think we can all agree. This is not pretty. But it's very doable. Stick with me. We can simplify this a little bit. Still have the limit as h goes to 0. This is not going away for a while. I like it best if it gets written every time so that it doesn't get forgotten about. The limit as h goes to 0 of 7 over 2 plus h minus 7 over 2 all over h. If I want to simplify this, this is the difference between two rational expressions. If I want to actually subtract these two things, which I do, I need a common denominator. So I'm going to multiply this by 2 plus h over 2 plus h, and I'm going to multiply this one by 2 over 2. That should give me a common denominator of 4 plus 2h on both halves. Let's see. The limit as h goes to 0 of 14 over 4 plus 2h minus, be very, very careful, this negative sign needs to hit both of these things. So for now I'll just leave it as a negative sign, but it's going to be 14 plus 7h, but both of those things are going to end up being subtracted when I distribute this negative sign. So be careful about that. 4 plus 2h. Still all over h. I successfully got a common denominator here. 4 plus 2h, 4 plus 2h. So now I can just subtract what's on top. I'll come over here to do that. At the limit as h goes to 0 of 14 minus 14 will give me 0. Negative 7h is what's left on top. Negative 7h over 4 plus 4h, sorry, 4 plus 2h is my denominator, divided by h. This is the result of subtracting these two fractions with their common denominator. I still have a compound fraction, so I'm going to resolve that by multiplying by the reciprocal. So I have the limit as h goes to 0 of negative 7h on top, 4 plus 2h on bottom. Instead of dividing all of that by h, I'm going to multiply by 1 over h, which should just cancel here and here. So I have the limit as h goes to 0 of negative 7 over 4 plus 2h. This is the step I mentioned earlier where the h from the bottom has canceled and it's gone. And now I can safely execute plan B by plugging in h equals 0 because the h in the denominator is gone. We still have this h, it is technically in a denominator, but there are other things in the denominator, so I'm not just going to immediately set the denominator equal to 0 when I plug in h equals 0. In fact, when I use plan B to take this limit, I'll get negative 7 over 4. So, I was expecting a gentle negative based on this graph, and I got a gentle negative based on all of this math. Checks out. The slope of the tangent line to this rational function when x equals negative 1 is approximately negative 2. A little, not quite negative 2. There is one more kind of function that I want to show you how to take a difference quotient of. So I don't think I have time to do that in this video. So stay tuned for part 3 of this.